string, and that goes on up and it provides your grounds all through the radio. Right here, what that is on this side, what they've got coming in on the power cord, here's your switch. It's on the potentiometer, I just said. And what that's doing, that's making a connection back to the power cord right off the minus side of the line. Now, one thing to note here, and this is why a lot of these radios are not totally safe. They have what they call as a resistor. What that's doing, this shows an arrow, but actually that should be a 4. And this is going right from B minus right here through this resistor. That happens to be 120K ohm. So with 120K ohm, the math is pretty simple. How much current or amps are we running on 120 volts down to the chassis? Anybody know offhand? Okay, it's 10 milliamps. Pretty easy because you got 120 volts and 120K ohm. Anyway, so you think, well, shoot, 10 milliamps is not a lot of current. It's probably not, but if you're talking about 120 volts AC, it probably won't kill you, but I'll tell you, you get hit with it, and it will wake you up. It'll light you up a little. It's no fun. So these radios stay as long as the same way that we moved the regression. So there we go. So what basically you have to do, because a lot of times you'll come in on the radio, and then you'll have one side of the power line come in, and the other side, of course, is originally going to be going to B minus. Well, a lot of times they will have tie-off points right here on the switch side of the switch, or the side that's going on the B minus side of the switch. And what you have to do when you're doing this kind of thing, it's really not too difficult if you think about it. You've got to take all those tie-offs for B minus off of here, obviously, because what we're going to want to do is use this switch to run the power side. So this has to be completely open, just like you see it here. Any of these tie-off points, a lot of times they'll run minus back over here to your potentiometer. A lot of times, so the pot is running to ground, or there may be another B minus line. You'll be able to find it, because wherever the other side of this wire goes, then you want to go to that. Sometimes it's just a matter of cutting the wire off. If it's just feeding B minus on it, that type of thing. So the main thing on this, we want this completely clean and nothing on here when we go ahead and do that. So go ahead and go back to or up to against that. So therefore, right here, then we don't have anything on the switch other than just this wire here coming in, and then this wire going to the rectifier coming back out. Okay. Any questions on that?
You take the resistor out then too, Mike?
No, that's for noise suppression. And once you get this thing wired correctly, that resistor is not going to cause you any problems at all. So anyhow, okay, go ahead, Scott, on the next.
Danger, Will Robinson.
Yeah, danger, Will Robinson. Anyhow, go on and on to the next one. This is our famous hot chassis radio. But before I go on to that, I guess I kind of got ahead of myself. I wanted to demonstrate real quick how these things can be dangerous, a little bit dangerous, in other words. And this is your floating B minus radio. And we'll go ahead and plug that guy in. This cord here is not polarized. You can plug this in either direction. And that's a lot of times where a lot of the problem comes in. So what you're gonna end up doing, you don't know when you plug that in. I don't know whether that's on the B minus side or if it's on the off side, you know, in conjunction with what you're plugging it into here. So unless you want to test it every time. So anyhow, I've got a wire here, and this is hooked directly just to the new or the ground wire on the outlet, or going back to ground. So what that'll do, that's going to show us, you know, if we have voltage on the radio. Now, this radio is off. We haven't turned it on. Hold on. So we're going to hook one side to the ground wire going back into the outlet, then the other side onto the chassis. Let's see what we end up with there. We'll go to AC voltage. And okay, so we have 0.02 or almost no volts on right now. So what happens if we take the plug, and that's obviously because when they plugged it in on the neutral side of the wire. So we'll switch it around that way. And it's making a liar out of me already. Oh, wait, there I go. No, I'm not getting it for some reason.
What's the power
Oh,
strip?
wait. Hello, I had it hooked up on the wrong side. Okay. 064. There we are. I just had the my lead in the wrong place. So 120 volts with the radio off. So what you'll end up with, and like, because I was telling you, since it's the floating B minus, it's going to be, go back one, Scott, sorry. A 2. Forgot about that guy. What you're going to end up with is right here, see, 120 k ohms. And like I was talking about, then that's your 10 milliamps of current. If you touch the chassis and you're grounded, which, you know, it could be grounded pretty good on this floor. Anyway, this radio here, its counterpart, is one that I have restored, and I took and changed the wiring. And I don't know if you can see it or not, but I'll show you anyway. I tried. Right on the power switch right here, this is where the wire comes in right here to the power switch, and then the hot wire from there goes right on over to the rectifier tube. So now that's this wire right here. In other words, this is wired up just like that. So we plug this one in, and it can only go in one direction because it's got a polarized plug. And that's ultimately why, you know, it's only going to go one direction. And no matter what you do with it, you know, and then I didn't turn that one on, but it just isn't going to make any difference. The radio is turned on, and we still have like 0.1 volts on here, which is like nothing. I can demonstrate that one too with it on. On most of these, and I think that's the way this one is that I believe this one is going to be hot, and that's the way this one played out too. It'll be hot on one side, and it will be with the radio on, 120 volts there with the radio on. So you're either going to get voltage on the chassis on this one with the radio on, and that's using the old, go back one other, Scott. Yeah, that's because now you have your hot wire going through the bottom the way the plug happens to be plugged in. Remember, it'll go either way. Then it's going straight over here, straight over there, and giving you 120 volts through that resistor to chassis. Then if you flip it around like that, and put it on, turn it off, 20 volts on it with the radio off, because it's going through here, and now your hot wire is going through this side, going up through all the filaments, through that resistor, through all of this, through there, and all the way back to ground. Now it's got this resistor here, plus all the resistance and all of the filaments, including the rectifier and that resistor. So you're probably going to have quite a bit even less current total when you add all of that up. So anyhow, that's kind of the demonstration on those. And I have one here. This thing here is really deadly, and so don't try this at home. And so what I like to do in situations like this, I'm going to turn the surge protector off, just so I don't get mixed up with this and screw up and get shocked or something. Because this stuff here, and I did a check on it, and it's well over 1,000 watts of power if you get hooked up with this sucker, because what it is, it's not anything to do with the radio. Now it's running it right through the plug in the wall, and it's giving full current out from one side to the other. So, and it says right on this thing, it says the chassis of this receiver is connected to one side of the supply line. Okay. Now, I will say they did a good job on this. Just the late 50s, early 60s radio, I think like 58, something like that, Zenith. They did do a good job of isolating, because to plug the, to get into the radio, if you got this radio back, has one of these protected power cords on it. So anytime you pull this back off, this power cord comes off the radio for safety, so then you don't get hooked up in it. And of course, it tells you don't defeat this purpose, which of course that's what we all do. We always, all of us get a cheater cord, you know, anybody that's working on one of these things. So, but this goes kind of hand in hand, is also to protect you when you are working on one of these and you do want to plug it in with a cheater cord. So then if you get the thing wired correctly and change the power switch around, put the neutral on the chassis, like I'm demonstrating, well, then while you're working on it, you want to check voltages, well, then now, not saying you can't get shocked, but now at least the chassis is not going to be dead hot with, you know, over 1,000 watts of power on it. So, huh?
How about the screws on the bottom?
There's no screws on the bottom. Screws are on the inside. That's what they really did a good job. Screws are on the inside, going horizontal. And then the other thing they did was on these knobs, you pull a knob off, like say you got a child wants to pull the knob off, you know, for the fun of it. You go in there, now the knob won't come out. It wiggle wobbles around because it's got a big washer on it, so you can't get this off. So they, same thing on the tuner knob, same deal. So they really did a real good job of isolating these things and making them safe, you know, and that type of thing. But I cheated here. I went and took a wire, this red wire, and I hooked it to the chassis. And it's, yeah, I'm cheating. So it's the same thing, and I don't want to get mixed up with it. So what I do in this instance, and maybe it's kind of a good idea, is I make all my connections first. And I'm not going to attempt to show current or anything on this thing, because all it's going to do is blow the fuse in the meter. That there. And let's see, the black side here is going to go to this wire here, which I have hooked to the ground safety wire and the plug. Okay, same sort of thing with the plug. Right now with the radio off, we got virtually 0 volts. This one's different in that it's a hot chassis, so you're going to have 0 volts no matter what you do with the on-off switch. Whereas with the floating V minus, it's different. But if we take the switch, oh, whoops, that's what's wrong. That's off. No, there we go, 120 volts. I'm on the right side. 120 volts there. You turn it on, it's still 120 volts, no matter what. And that's what really makes these things dangerous. So it comes back to doing the same thing. Turn that off, unplug the radio, take this off. Okay. Comes back to the same thing. This radio here was one that Myron White loaned me for the demonstration, and in turn what I did was I made the radio safe. This is a 1940 Emerson, and it was built with a hot chassis. And so what we did on that one, go to the next screen, Scott, please. Next one, yeah. Yeah, making a hot chassis safe. Here we go, the same deal is right here. You can see the switch from it. What happens if you look at this schematic? This goes back, and here's your B minus coming off the end of the filament string, and it goes over here, and it goes directly right to the chassis. So this radio is a direct hot chassis radio. There's no resistor, there's no nothing on this thing. So you have your switch. We move up here on the power side, comes over here, goes over around, and goes. This is the filament for the rectifier right here, 35C5. We're showing it separate. And here it is with the tap going to the pilot lamp, all of that business. And now with the radio that way, and it has a polarized plug. So now we're not going to get bit by anything. I'll show you once you do one of these, and the hot chassis are actually the easier ones to do. Because all you do is you take your neutral wire, the one that's connected to the wide spade, here on this end of the wire, these, and then I usually ohm check them to see which wire I'm dealing with. You just run that thing directly to the chassis or the radio, and that's what I did on this. And then, of course, then the hot side, you change it over and run the hot side to feed the rectifier filaments and all the rest of the filament string from there. That's how it works. So we'll plug this in, and this is another one of those that would kill you. It's another one of those that has 120 volts on it normally. And I've got tangled wires all over this, don't I? So we'll turn the voltmeter back on and get a good place here. And we have no voltage on it at all. That's because the neutral wire right up here, and of course now right there is your wide spade is going over through here, and that's the neutral, and the neutral is always connected to the chassis. The hot wire goes through here and goes into the switch. Let me turn it on, demonstrate. With it on, it makes any difference. Oops. Plug it in. Same deal with the radio on, no voltage. So it's always going to be safe, even though originally from the factory, this is a deadly hot chassis radio. And this one's cool. And this was kind of bad because, normally it would have a back on it, and I think if you didn't fix it, that's the least you'd want to do is put a radio back on it, because you can get in there and you can touch the chassis, all day long. And now it doesn't hurt you at all. There's nothing. So anyhow, any questions on any of this stuff? I think that's it. Mike.
Why did they do that back in the day?
They didn't have polarized plugs and modern wiring. So back in that's why. They didn't really have any option other than to put the switch on the negative side or the B minus side of the radio, and then let the hot side go up into the radio. That's the way they designed most of it. This one here is dated in 58. Now, what they did, this thing's going to be super easy to fix, because they actually put the switch the other way around. The switch is actually on the hot side already, but the negative side, or the neutral wire, is hooked right to the. No. One of the two wires, rather, I should say, is hooked to the chassis. And it's a 50-50 chance which way you're going to plug it in, whether it's going to be safe or hot. So that's the trouble with that. So to fix this radio, really all you need to do is make it polarized. Now I have also, and where did I do? Oh, here we go. You can get these little things here, and I thought, few of them. You can get them like anywhere, Amazon, Mauser, and they are polarized plugs that you can add to. Just cut the plug off of one of these radios that has the cord going up in through the back like that. You got one or two options. You can either just cut the plug off and then put one of these on, and of course you're going to have to test it to find out which side is going to be your B minus, or in this case, which is actually going to the chassis. So it makes it fairly easy which side you want to put this on. But you have to be careful when you put it on here that you get this on the cord the correct way. Otherwise, you're going to put the hot wire on the chassis to keep the whole thing. You can either do that, or if you wanted to, you could take one of these cords like this. You could just, and it might be maybe look a little nicer. You could just cut this cord someplace, and then solder the wires together. Heat shrink tubing in there, maybe heat shrink the whole outside of it. Looks very nice. You can go that route, or you can use one of these plugs here. Either way. So that's and then as far as okay, go to the next one, Mike. Yeah, testing your work basically comes down to what I just did. Now I don't know if you want to go to the elaborate of making one of these plugs or not. They're kind of nice because it gives you a source of ground. And what I did was I took this little wire and I ran in and I hooked it only to the grounding wire only. So this one and this one aren't hooked to anything at all. So it's kind of a neat little tool for checking because you can always have a ground source that you can hook to on any radio, and then you can check to see what voltage current is, that type of thing. Another useful tool is you can get one of these devices to plug into the wall. It's called a kilowatt. And what that'll do is really nice because you can plug a radio into this device and it will tell you current, voltage, and cycle hertz, that type of thing, and give you all sorts of great information. And then just by having that thing plugged into the wall and plug your radio, now you can see what kind of watts, I'm sorry, what kind of wattage the radio is pulling, that type of thing. Very useful tool to use. So, but basically as far as testing is concerned, is basically what I just did. The first thing, of course, you want to do is make sure that your outlets in your house are wired correctly with one of these tools. And then from there, if they are, then you can go ahead and check your radio when you get done with it and make sure that it now is safe and the chassis is cold. So any other questions? Jeff?
Yeah, what do you think the purpose was of manufacturers making a hot chassis? She make a cheaper radio?
Yeah, I think it was just cost, as far as I can tell. Well, yeah, that's the first thing. Just making an AC/DC radio at all is not having a power transformer. They were able to accomplish that simply through the filament string, that type of thing, and your AC/DC all-American 5 power supply. But as far as a hot chassis is concerned, it meant that they didn't have to run a whole bunch of B minus bus wires all through the whole set. They just connected everything to the chassis and called it good. And then they said, well, let's just put a good radio back on it. And then these knobs that don't come off and do all of that sort of business, to save money on the manufacturing. So anyhow, Mike?
Yeah, instead of the non-contact voltage testers for your house, I actually recommend one of the little polarity checkers you can get with the 3 lights on it.
Oh yeah, those are nice.
Because it not only will guarantee to check it in, you don't have to remember wide versus small.
Mhm.
But it'll also check to make sure that you actually have a good ground, because it's possible you might have an outlet that doesn't have a ground. And it'll show you that.
Oh, that is, did you hear what Mike had to say? They're 3
They're receptacle
checkers, and they have what, 3 LEDs in them? And
Yeah, 2 red and a yellow.
2 reds, yeah, you can get those at Home Depot or anywhere. And those are really handy to use. Yeah, that's a good point. Good idea. So anyway, yes, George.
I'd like to tell a little story about that. Is
Okay.
that okay?
Yeah.
All right. In Texas, the Rogers Organ Company put in a new organ, and an amplifier up in the tower and the speakers. And when the socket was an old-fashioned socket, so the electrician that went to that church, or whoever it was, he was, went and switched the neutral and didn't hook up the ground. And so the neutral and the hot had been switched. Well, you can plug the organ in and it has isolation and it wouldn't hurt. I know, I designed it. But the amplifier up in the thing was a different story. It had a different orientation and they had a bonfire. And the bonfire, I had mitigate, and I had a fly there. The insurance company did not. They blamed the organ company until I proved to them what had happened, and the fact that the amplifier ground was correct in the belt in the upstairs, but it was reversed down into the organ feed. So consequently, the insurance company, he argued like crazy, but he lost and they had to pay for it. Because the man in the church who was not trained caused the problem. And you know, there's a lot of that, as Mike has.
Oh, yeah, you get homeowners. They don't know, I want to hook it up, they can buy a car on one side or the other. And there's nothing to stop anybody from doing that, the way these outlets are built, So, but that's why you always want to check it. Did everybody get one of the radio wrinkle articles here? I'm not sure how many got out or if this is gonna work or not, we'll see. If you want to look, everybody look back on your third page next to the end, and see if you have, I think it's an orange dot at the bottom. We may not have handed out enough for this to work. Well, you're gonna get something, but I don't know, I mean, we may not have handed out enough. Anybody got that? You have it? You do? Okay. You're the proud owner of an All-American 5-miniature tube set.
Awesome.
Yeah.
All right. Thanks, Mike.
Thanks,
Thank you,
everybody.
Mike. Wonderful guy.